Good morning and welcome everyone. I'm Almudena Claudio, Director of Technological and Digital Innovation of the Spanish Foundation for Science and Technology. I'm delighted to be here today in a meeting where, through visualizations, we will see the functionalities of the STI Viewer tool within the R&D artificial intelligence use case. The format of this meeting is hybrid, so we have people connected by Teams. The event will be recorded and the presentations and video will be posted in the Intelcomp website in the coming days. You can send your questions through the Teams chat where you will share the terms of participation. We also would love to know your opinion about the visualizations and indicators that we are going to show here today, both those of us who are here and those who are online. And now I would like you to introduce yourself briefly, both those who are here and those who are remote. Thanks. We start with Joseba San Martin from FECIT.
Thank you, Almudena. Hello, my name is Joseba San Martin. I'm a policy analyst here at FECIT, and I'm coordinating this project together with FECIT's team and also with the assistance of the Carlos III team, the University of Carlos III technical team led by Jerónimo. Thanks for coming.
Okay. And David Gago?
Thank you very much, Almudena. I'm David Gago, and I'm the coordinator of the Artificial Intelligence Living Lab carried out by Silvia. Thank you for your attention.
Thank you. And David Perez Fernandez. I don't know if it's connected. Sorry. No, it's not connected. No. Sorry.
No.
Sorry. Okay. We will start with the people who are here. It's easier.
Hello, my name is Lorena. I'm working at Entity Data in communication tasks.
Okay, thank you.
Okay. Hello, my name is Daniel Jimenez from Entity Data also. We are responsible of the exploitation, business models, functionality of the project, and we are here to listen about the tools that are developing during the project.
Hello, my name is Maria Barroso. I work in SEDIA. I with a coordinator with David Gago in this consortium.
Okay, thank you.
Hello, I'm Rafael Martinez. I work as Intelcomp Technical in the SEDIA.
Hello, good morning. My name is Torben Bete and I'm working as a project manager with an Intelcomp project.
Okay.
You from FECIT.
We can continue with the people who are remote. For example,
Sergio, no? Sergio. Yeah, here. Sergio, go ahead.
Sergio de Virgilio. Please.
Good morning. Can you hear me?
Yes.
Good morning, everyone. So I'm Sergio de Virgilio. I hope I'm the only Sergio there. And I'm basically working as policy analyst at the European Commission in the unit of data and knowledge management, and involved in the development of advanced visualization and analytics techniques such as machine learning, deep learning, and also large language model, developing these kind of tools for the internal use first since quite a number of years now.
Okay, thank you. Juan Ignacio Fernández Paga.
Hi, I'm Juan Ignacio Fernández Abad, and I work on the CEDIA's cabinet, the cabinet of the Secretary of State. I'm a coordinator too.
Okay, thank you. Basileus.
Good morning, everyone. Can you hear me?
Yes.
Yes.
My name is Vasilis Mongolidis. I am at Athens currently. I work at General Secretariat for Research and Innovation. Have a nice meeting.
Thank you.
Thank you. Inés Rodríguez.
Hi, I am collaborating with the SEDIAS team.
Sorry, we can't hear you. It's very low. Okay. Jerónimo Arenas.
Hello, everyone. Good morning. My name is Jerónimo Arenas. I work at Carlos III, and I'm involved with the Intelcomp project, several work packages. I'm actually the technical manager of the project.
Okay, thank you. Juan Miguel Márquez.
Hello, I am Juan Miguel Márquez. I'm from the Red.es, the National Observatory of Technology and Society in Spain.
Okay, thank you. Paresa Marchiani-Do.
Yeah, good morning, everyone. My name is Paresa Marchiani-Do. I'm from Technopolis Group, and I'm part of the consortium leading the works under Work Package 1, which is the conceptual framework.
Okay, thank you. Tessa Enoch.
Yes, hello. I am Tessa Enoch-Lévy. I am from HCRS, which is a French institution in charge of evaluation. And I am working in Intelcomp project in charge of the living lab about cancer.
Okay, thank you. Dioxios Diamantis.
Hello everyone, I'm Dioxios Diamantis. I work for an SMB in Greece called SITE. We're involved in the Intelcomp project where we develop and contribute to some of the platform tools.
Thank you. Utku Demir.
Yes, hi everyone. I assume you can hear me. Hi everyone, my name is Utku Demir from CTSI, Center for Social Innovation. We are a social scientific research institute. I am working here as a research assistant and project manager. Me and my colleague Dietmar Lampert, we are leading the Work Package 6 Living Lab activities in Intelcomp project. Yo.
Mantoy Kidoy. Sorry if I don't spell it well. Sorry.
Elina? I think it's Elina.
Elina. Oh, Elina. Okay, sorry. Elina Manto. Okay. Then Gonzalo. No. Okay. Then we are all. So I give the floor to my partner, to Sebastian Martin.
Thank you.
Thanks a lot.
Hi, sorry, I couldn't hear you before because I had a problem with my with the sound of my and the camera, but I will fix it. I'm Melina. I'm trying to write the name in English, and I have a problem with the internet connection because we had some floods here in the morning. We had some severe weather conditions, so we're trying now to restore some things. I'm Melina Pantou, and I'm from HFRI, Hellenic Foundation for Research and Innovation from Greece.
Okay, thank you.
Okay, thank you very much.
Okay. Hello. Now, first of all, we are going to do just a quick review of the status of the project. Then we move on to a short introduction of the STI Viewer tool, and then David is going to do a demo of the tool. Okay, so where we are and next steps in the development of the Intelcomp platform. Well, just a quick reminder of what is Intelcomp. Intelcomp is a platform to improve and automatize the task of managers of R&D programs at ministries and funding agencies by exploiting millions of documents with text analytics. The justification of the rationale for this project is that we have now digital records of all STI activities, and we have seen a big evolution as you know, in all the techniques of text analysis. So our aim is to gain novel insights from the STI data. The platform has been successfully tested by public administrations in 3 use cases. First of all, the use case here in Spain, led by the Secretary of State for Digitalization and Artificial Intelligence. And the use case is about the R&D in artificial intelligence techniques. The second living lab is the one that Tessa presented, is about the cancer research, and our public administrations there are several institutes in France dealing with cancer research. And the third one is the third use case is the R&D in agri-food and energy in Greece. So what services and tools do we have now in production? The platform already provides solutions to ingest data, pre-process the text, and translate millions of documents. We've also developed a collection of services that add value to this text data. First of all, a domain classifier to identify documents in a domain. For instance, we have selected with this classifier the documents, the publications, the projects in the cancer domain. The second service that we have, there are several automatic classifiers developed by the BCC team, here the Barcelona Supercomputing Center team, and also the Athena Research Center team, to assign documents to well-known taxonomies, for instance, the field of science of the Frascati manual of the OECD, and also other taxonomies. The third service is the topic modeling services that we have developed. We have been developing topic modeling services for several years here in SEDIA. So, as you know, we are more or less at the state of the art in these services. And last, we have several software components for the computation, processing, and analysis of graph collections. Okay. Let me move on. This is important. As Sergio has mentioned, here we have also benefit from large language models in developing these services that running over GPUs. All these services have been integrated into a tool. This is one of the tools that we have developed, is the interactive model trainer. This is the heart of the platform, where we train models incorporating information from experts in a domain. So this is, as we said in the proposal, a human-in-the-loop approach to develop these models. For that, we need experts in these domains, experts in cancer, in the case of France, experts here in R&D in AI, and also experts in agri-food and in energy in the other use case. All these models, these topic models, nurture the end-user tools of the platform. One of these tools is the tool that we are going to show today. That's already deployed. Is the STI Viewer. With the models of the interactive model trainers, we calculate a series of indicators that we show in the STI Viewer. Well, you can find all of the services, most of them are already available, publicly available in our GitHub account. We have also published several scientific publications, and also all the public deliverables of the project are in our website, where you can see all the services, all the software. It's already there. And well, the next steps, complete the development and test the other user tools. The first one is the STI Policy Participation Portal. This is a tool to involve the other policy stakeholders, the citizen associations, academia, industry, to provide feedback on STI policy, on STI programs. The second one is the evaluation workbench tool. This is more or less an evolution, I would say a complete redesign of the corpus viewer that SEDIA developed in the past to assist call managers in the evaluation of grant applications. And the third one is the graph visualizers, when we see all these big graphs with millions of nodes. Okay. The second next step is to finish the integration and the deployment at the Barcelona Supercomputing Center. Our aim is to have a common, flexible, incremental, and highly scalable architecture for all possible use cases in STI policies. And now we are defining also the business models to exploit the platform. Okay. I will now just give you, if you have any question, maybe we can stop here. Do you have any questions, someone? Yes? Go ahead. Vasilios, go ahead.
Yes, thank you. I must apologize because I'm doing in parallel different things. You know, in ministries, there's always urgent things. I heard at some point that you have tested or a use case on agriculture things. Could you please clarify a bit where the data were taken from? What was exactly been done?
Okay, thank you. Well, the use case in agri-food and in energy is led by our Athena Research Center team. Okay, in fact, they have already celebrated several workshops as this one. This one is about the use case in R&D in AI. Okay. But there is another use case that is about energy and agri-food. That's where the ARC team is working, okay? And the data that they have, well, I'm not going into the details of all the data because they have already developed, in fact, quite a lot of indicators for agri-food and energy. There's going to be a workshop on I think it's the 6th of October. 5, I think. 5th, the 5th, okay. The 5th of October. We are going to invite you, okay? And that's about the climate. We say climate, but it's agri-food and energy living lab. And also regarding another use case in Greece, what we have is one of the tools that I've just mentioned is the evaluation workbench. Is a tool to help in the evaluation of proposals for funding. And with that, we are working with ELIDEC. Okay, we are working with HFRI, and they are giving us the requirements to define this tool. With Elena is here, and those are the use cases in Greece. One is about energy and agri-food, the R&D landscape in Greece, I would say, and the other one is about the evaluation of proposals in HFRI. Okay. Okay,
thank you. I will wait for the invitation for the next meeting you mentioned. Thank you very much.
Thank you. Any other question? No? Okay. Then we move on to the quick introduction to the STI Viewer tool. Okay. The STI Viewer is an interactive tool to visualize and explore a wide range of indicators on research and innovation activities. It features, as David is going to show, business intelligence dashboards showing a set of indicators that can be sliced across multiple dimensions, for instance, scientific or technology domain or geographical area, and it presents complex data in an accessible and user-friendly manner. Okay, this is more or less the description of the tool, its users, policy analysts, administrators, and funding agencies managing programs or calls that support R&D activities, and the tasks that where this tool can be used. The first one is to analyze the context and the problem or challenge that justifies a program. With the STI Viewer, we can identify and understand trends in R&D activities. For instance, to recognize the most promising research topics. That's something that we have been doing for years. And also some new information using, for instance, the websites that we are doing this in Spain. We are not going to show it today, but we are working on that. We have already a database of websites, and from that we can extract from the description, the text in the website, we can describe the characteristics of the firms using AI. And the other task where we can use this tool is to assist in the monitoring of the results of programs or calls. We can use textual data to describe the outputs of the R&D projects. I would say this second functionality, we need linked data to do that. We need the funded projects and also the results. This is what, for instance, OpenAir has given us, the OpenAir dataset. Okay. How this is more or less. We started the project 2.5 years ago. So this is more or less from the beginning of the project, the theoretical framework that Paresa mentioned. How did we define the indicators in the STI Viewer? We had a theoretical framework that combines the functions of the innovation system with the stages of the policy cycle, and we formulated a lot of questions in this matrix combining these two aspects. For instance, I don't know if it's clear enough, but we have, for instance, one of the functions is entrepreneurial activity, and agenda setting is one of the stages of the policy cycle. And we have formulated in total more than 100 questions. And from that, we focused for this project in the agenda setting. That's what I mentioned before, the definition of the context and the evaluation stages of the policy cycle. And conceived from those questions, we conceived a long list of indicators. This is how we define, we select these indicators. We ask ourselves if the indicator requires text analytics, that's the added value of the project, if we could source sufficient data, if it is technically feasible, if it's in the scope of this of our project, and also if it's in the scope per the domain, in this case today R&D in AI, and if it has been validated by our Living Lab, by our Sevilla colleagues here present. Okay. And this is more or less the workflow from the policy questions to the visualizations in the STI Viewer. So we started with policy questions, then we defined indicators. Living Labs refine these indicators. Technical teams, if they technical teams of the project, of the consortium, give their okay if these indicators can be calculated. We also gather the different data sources. We use the different ETL services to ingest the data. We also use a lot of pre-processing workflows developed by the BCC team and also the translation team by one of our partners, a firm applied in machine translation, that's Tilde. Once we have the pre-processed data, we applied all the text analysis services that we have developed, as I mentioned before, the classifiers, the topic modeling services, the graph services, and we put all that in the interactive model trainer, where we develop models together with experts in domain, in this case AI. Once we have the annotated data, we generate the indicators and we show them in the STI Viewer. That's what we are going to do right now. So any questions? If not, we go on to the demo. Yes? Sergio, go ahead.
Yes, thank you very much for this presentation. I would like to raise 2 points here before we get into really the technicalities of the tool. The first one is regard the fact that you have developed a use case in different countries, which I perfectly understand. So expert in agri-food or in cancer or in artificial intelligence. And I was wondering if you have envisaged at some point to test the acceptance of these environment with members from other countries with the same kind of specificity, if you can find them already are available, to see a little bit the level of acceptance of the point of view that is developed and in the use case. I'm taking my head here of a European Commission representative in the sense that for us the question is always how can this concept and this context be spread across member states or associated member, which is an important element. And the second question is about regarding, as you say in your process, you are looking for developing the indicator. When you look at the indicator, you see what are the sources that are needed to address these questions. Are you looking also at the stability of those sources, in the sense that you know that one of the main issues is either the kind of opposition between proprietary and open source, which give a certain quality or a certain lack of quality, and also the fact that those sources over time evolve quite a lot. Are you envisaging plan B or fallback solutions if for whatever reason we have experimented this quite a lot in the recent years of disappearing source of information that were very valuable, very high quality, but unfortunately were not supported anymore for tons of reasons, I would say. Thank you.
Thank you, Sergio. Thank you very much. Okay, regarding the first question was about the, if I understood it correctly, about the acceptance of the tools with other countries and how if we can validate the results in one country and also to other countries. I would say, in fact, as we are going to show, our results are also we define the questions not at the first at the level of the country, but we define the questions and also the theoretical framework at the level of the EU. So in fact, you were also involved, Sergio, in the validation of these needs, of these domain needs, and we did it at the level of the EU. It's true that then we move on to the country cases, and there we have been also comparing the results in the countries with the results at the EU level. Okay, so we are going to show today results not only at the country level but also at the EU level. It's true that the people that has been involved mostly in our living labs has been in agri-food. That will be people from Greek authorities here from Spain. And it's true that we need to validate these results also with other countries. I think it's for the next phase of when we can exploit the platform, and we hope these results are going to be robust enough. It depends also, as you know, on the data that we have for the different countries. Regarding the second question, the stability of the sources, well, you are completely right. In fact, we have been we use the project is not about ingesting or gathering different data sets. It's not the project is about creating a platform. That's what we are doing, and we test it with different data sources. Okay, and in this process, what we did, in fact, was I would say that our colleagues have improved also the quality of, for instance, of OpenAir. That's our main the OpenAir research graph, our AIM database. And when calculating the indicators, we have seen several, I would say, well, things that are not perfectly in the data sets, and we have asked OpenAir to check that. So that's why one of the things that we are doing. Regarding maintenance, I would say, well, the platform this is about a platform. It's not about the data set. So we are going to see when users and when we exploit the platform, for instance, for OpenAir, we are doing periodical updates, but for other data sets, it's just a one shot. Okay.
Thank you.
Thank you, Sergio.
If I may add, maybe Joseba, because indeed the representativeness of open air, for instance, in the topics that we have selected, also in the energy domain, in agri-food, it is part of the objectives in our last deliverable to look a bit at the representativeness of the data by comparing it to other sources such as Scopus Elsevier, in order to give also to the policymaker. Since we are developing this tool for policymakers as examples of analytics that have actually a good, robust outcome that can directly be used. So in the case of open air, certainly we envision some comparisons with Scopus. In the case of other sources, and we can of course keep on discussing for the sources, but in the case of PATSTAT, I mean, we are quite confident there in terms of source, because it's not fully complete, but it is the best available source when it comes to patents, for instance. So on that level, we feel a bit more confident, but we will have these discussions also more in detail as we develop specific use cases towards the end of the project. Thank you.
Thank you, Paresa.
Okay, thank you very much, Paresa. Thank you very much, Joseba, for your presentation. Thank you very much to FECIT for hosting this event. Before starting my presentation, I have noticed that there are new people in the event. So please go ahead and introduce yourself. I have noticed that there are 3 new members. So please, Noelia Virto, are you there?
Yes.
No? Okay, let's proceed with Maria Nogales, please. Okay, and then finally, Lauren Maxwell. They dropped, maybe? Okay, that's fine. In any case, okay, I will start my presentation. So my speech will be basically devoted to explaining the underpinnings of the STI Viewer and what is inside this Intelcomp tool. So this tool is part of an ecosystem, as Joseba has just mentioned, because I mean Intelcomp may be considered as an harmonious puzzle where different pieces at the end of the day add up. The indicators and the visualizations that are part of the STI Viewer are only the tip of the iceberg, because a great bulk of hard work underlies this, the obtention of the indicators that are in the STI Viewer. Obviously, besides the explanation of this underlying work, in this session we are also proceeding with a brief demo to share briefly how this tool works and what kind of information is available at the moment. So let me, on the other hand, emphasize that Jerónimo Arenas, who is the technical manager of the project, and also Diamantis from CITE, who is responsible for the visualization tools, are present here. So this means that some of the prominent figures of the STI Viewer are with us. So this is important for you if you want to get more information about how this tool works and has been built. Okay, so let me go back to the origins to emphasize that CIDIA, the Spanish Secretary of State of Artificial Intelligence and Digitalization, was commissioned to deliver a AI, artificial intelligence use case in the context of this Intelcomp project. So this was envisioned as a living lab type work, in the sense that co-creation, collaboration, cooperation among stakeholders was given a key role. Several shifts have been operated in the use case throughout these months.
But at the end of the day, this use case is basically aimed at providing a full picture of not only the Spanish STI AI ecosystem, but also the European AI STI ecosystem to optimize policy action. As you may also see from the slide, there are two complementary secondary goals attached to this use case. This is just a kind of reminder, but let's start with important things on the presentation, and this is about the real value of the STI. So the real value of the STI is not the visualization engine, which is attractive, and this is important obviously, but not very much different from others you are probably familiar with. But what makes STI different is how the different indicators have been built. And in this sense, as Joseba has just mentioned, there are two functionalities that are critical for the STI. The first functionality is the domain classification, the AI domain classification, and the second one is the AI topic modeling. So if we start with the domain classification, so the basic point, the starting point was the selection of 266 AI keywords that are domain specific, and also curated by experts. And these have been used to build two different data sets. Okay. So first data set that was called dataset 1 was publications that contain, and let's concentrate on basically publications. There are some other data sets on publications, patent projects, but for the time being and for clarity's sake, I will concentrate on publication. So how the data set has been built. So first of all, publications containing at least one keyword in the title or in the summary. The summary means the abstract, description, etc. Were selected, and this is called the dataset 1. Okay, and then a second dataset was created. This second dataset contains only the documents where the number of keywords or occurrence was above a threshold, and this threshold was set up to 3, and this is called the dataset 3. So then we plot the distribution of the number of documents against the number of keywords, as you see in the slide. So in the slide, what you see is the cumulative number of papers in C2 is Semantic Scholar, which is a database, very known database, and in the right-hand side, what you have is the same, but with a different database. And in this case, we plot OpenAir instead of Semantic Scholar. And what you see is that in the case of Semantic Scholar, the number of papers with at least one keyword, one of the 266 keywords, amounted to more than 2 million papers. If we restrict the analysis and the search to papers with three or more than three keywords, the number of papers is not so big, not so huge, but very, very important, and it amounted to more than 600,000. So the same applies to OpenAir with similar results. If we go to patents, for example, or if we go to EU projects with the database Cordis, the picture is very much similar. So this is the first tool. This is the first functionality, which is the domain classification. And then we should also include the second tool, and the second tool is topic modeling. Topic modeling, you know that this is about clustering topics, and in order to proceed with the clustering, we need some kind of coherence measures. Then you have here in this slide two different type of measuring coherence, and in both cases, the number of topics that were more coherent according to the statistics, so to the test, was 25, between 25 and 30. But at the end of the day, 25 topics were selected because we plot the topics selected in this kind of bubble map. We know and we notice, we see that in 25 topic bubbles, we don't have overlappings. Whereas if we plot 30 topics, which is not in the slide, we would see that some topics are overlapped. So that's why 25 topics were selected as the topic to be plotted in the STI viewer. Okay, so this is more or less about what is inside the STI viewer. And then I will proceed, because time is running out, I will proceed very briefly with the demo, with the demonstration. But before proceeding with the demo, let me just share with you that the type of information and the indicators that are available in the STI viewer. So in principle, there are 6 different fields of information that will contain information. So far, we only have information on science, technology, and industry. In fact, for the AI use case, we only have ingested information for science and technology. Industry will be available in brief, and the ESG reports, green skills and regulation fields will be covered in due time, not now. And what about research projects? Because research projects, is a very interesting topic for policymakers. We are going to cover research projects, but not in the STI viewer, because as I mentioned, and Joseba has mentioned before, Intelcom is made up of different pieces, and the STI viewer is only one piece of the ecosystem. So that's why research projects won't be covered here in the STI viewer, but will be covered in the subsequent functionalities. Basically, the STI participation portal, and overall, the evaluation workbench, which is a tool that is being developed, is being carried out right now. In our case, we are expecting to incorporate the EU Cordis database for the European level, and also the Spanish Spanish research agency projects that will be also covered in due time. Okay, so then I think it's time to proceed with the demo. I will try to do it here. Okay, that's fine. So this is the landing page of the STI viewer. So obviously, to be given access, you have to ask for a username and a password. Once we have login and we are in this landing page, we can also we can access the data. As you see, we have data from two domains. So we have data from AI, which is our use case, and we have also information from the climate change use case that was of your interest. But let's concentrate on our use case, which is AI. Okay, and then you see that we have information both for Europe and Spain. Okay, as this is a very brief demo, I will concentrate basically on specific indicators. So in order to access the information, then you click on, for example, EU. Then the category AI is open. Then we click on AI, and then we arrive at this page, you see here that we have three different numbers, very big numbers: the number of publications, the number of citations, and the number of publications cited in patents. These are the total publications, citations, and publications cited in patents that were delivered in the European Union from 1990 to 2022. Okay, so this is kind of a summary of publications, summary of citations, and summary of publications cited in patents. So if we concentrate on the first topic, because we have many indicators and many graph visualizations, but I will select particular ones. So let's concentrate on the first one. This is about publications in AI over time. Obviously, you have here the possibility of share this information. You have also the possibility to download the image. You have also the possibility of purely download data in order to proceed with to create your own graphs. And you can also download the JSON data. You have a bar here, and this bar implies that you can concentrate on a particular subset. If you, for example, are more interested in I don't know, the mid 20s, but you can concentrate on this. And what you can do as well, if you press here in this button, you see the same. You see the same, but with the, you see, these are the different 25 topics that were selected. You remember when we referred to the 25 topics? These are the 25 topics. Maybe there are not, I mean, you can see all the topics here, but if you scroll down, you will be able to access the topic, all the topics, because this is 1 out of 3. This is, sorry, 2 out of 3. Sorry. 2 out of 3 here. See the different topics. And this is quite interesting because you see how the different topics around the AI evolve over time from 1990, that was taken as the starting point, until 2020 approximately. Okay, so let's concentrate on a second one. For example, this is a map, and this is about the publications by country. Okay, you see the different the number of publications across the world, and you see, for example, in the case of Spain, if you hover over this the map, you will end up having the number of publications in AI in Spain, according to OpenAir. If you go, for example, to France, this is a top publication country. This is the amount of publications that were published in France in this time span, and so on. We can do the same, for example, for the top 50 journals where the publications were more popular, and the same here. We can go through this bar, and we can select a higher number of publications, up to 50. Okay. The scientific impact trends, for example, we have the publications in the bar, and we have in the green line. This is the publications that are cited in patents, and you can see how these two series are up to about correlated. Okay, so this is about European Union. Okay, if we do the same for Spain, we have some data. I mean, basically the type of information is the same, but we have some gaps that hopefully will be covered. But you see here, this is the same graph as in the European Union, and then we have the same with the different topics, and this is for Spain. Okay, so if you scroll down, you will have the same information, but only applied to Spain. As the time is running up, and we should be punctual to finish, and to allow for some questions or some doubts, what I'm going to do is just to finish with a little demo on technology, the technology indicators. You see here, we have science, I mentioned, we have science, technology, industry, ESG reports, displays, and regulations. So we have some information on technology. This is the number of patents. You see here the number of patents over time. The reason why there's a sharp decrease in the last years, I suppose, is that not all information has been ingested. So this has been updated, and that's why we have this very weird profile. And the same here, we have also the technological production origins, the patents by country. Or what you see here is, that the United States is very much the leader in terms of patents in the AI. So compare, for example, United States with I don't know, maybe Germany. This is a top performer country. And then we have also China. Yes, China. Let's see China. China is yes, it's below Germany. Probably these figures will be completely different if we update the information over the next years. Then here we have here the patents in terms of the NACE code. You see this information that is quite interesting. And then if you press here in this second button, we have information. Let's see this information. This is about patents by IPC code. Okay, and you can also scroll down the bar in order to allow for more information. So this is basically what we wanted to share with you. The work is in progress. So this is a kind of draft and demo version of this tool. So I would like to know some kind of feedback from you before leaving the session, or you want to a question or wherever, any suggestion, any comment will be more than welcome. So thank you very much for your attention, and go ahead, please. I think there's a person with the hand raised. Juan Ignacio Fernandez, please.
Yeah, thank you for your presentation. And I want to ask if we could have, for example, access to the number of patents based on technology sector and number of patents, but we could research the paper of that pattern, for example, the title, to be more specific. For example, you have got sanitary, but which part of sanitary, or vehicles, but they are components of vehicles. They are so check the patterns in that case, or other kind of data to be more specific. So we have got the numbers, but we could have got access to the papers itself, or
yeah. In the case of the patents, we have first of all the NACE code. We have the IPC, and what we have also is the topic modeling has been undertaken in the case of patents. I haven't mentioned this, so I have mentioned how the topic modeling has been implemented in the case of publications, but the same applied in the case of patents. The topic modeling hasn't been exactly 100% the same in the case of publications, because we had different kind of patents. So in fact, we had topics related to AI techniques that were highlighted in green. So we can, if you are interested in this, we can discuss this a bit later, or maybe in Cedia or whatever, because it's a very interesting point. But in the case of patents, we have topics related to AI techniques, and this accounted about 25–30% of the patents. Then we have also topics that were related to applications, and for example, the case of bagging and packaging and vehicle monitoring. It was this type of topics, and we also distinguish in topic modeling applied to patents. We also have topics related to AI, but that were in areas where patents may be applied. For example, image recognition or sound signal analysis. So yes, we had the same procedure with patents. So we also applied a topic modeling model for patents with 25 topics. So if you want to know more about this, I can share more information.
Let me help you, David. Maybe what we have in the STI Viewer are aggregated results. Okay. I think if I understood you correctly, you mean the individual patents or the individual papers that were cited in patents. This is the PatStat database. We are using the PatStat database. All this information is in the PatStat database. But our added value is not to go into the details of the PatStat database or to go into a specific patent and to know the papers that are cited in this patent. I would say our added value here is, as David has explained in detail, is to go into a different classification that is not the IPC codes. What we are doing here is topic modeling is a different classification that goes across these IPC codes, and it's the topic modeling. Here, I think our added value is twofold. On one hand, is the definition of the patents in AI. That's not easy. How we define patents in AI, and our second added value here is the topic modeling.
Yes, look, this is I found this interesting graph. This is the patents, the number of patents by topic, and the topic has been created with topic modeling, and this topic modeling was undertaken in a different tool of Intelcomp that is called Interactive Model Trainer. So we developed a seminar on the Interactive Model Trainer in June, and we explain how this functionality works. So once we have developed this topic modeling, we will end up having the classification of the patents that are ingested in or are available in PatStat. This is the classification according to the model we have developed, and then we have here the 25 topics that arose or the flourished when we implemented this model. Anyway, Jerónimo Arenas from the University Carlos III was the brainchild of the Interactive Model Trainer, and he was the responsible of undertaking these models. I don't know if Jero, if you want to add something else on this.
Yes, I actually had my hand raised. Yeah, just a couple of comments. Maybe the first one, the patents that you are showing, I'm not sure you mentioned, only applies to patents that were presented through the European Patent Office. That's also maybe why China is not, very high in the count of patents, because probably they are presenting a lot of patents in authority. Okay, so this is only presented through the EPO. Okay, and then of course, even though it goes through EPO, we might have authors from other countries. It's not only Europe. That's why also we have United States, but that's the use case that we are analyzing here. And also regarding your comment, I basically agree with what David has said. I mean, this is the use case that we are analyzing. It's the whole of the patents or the publications that fall in scope of artificial intelligence. If we were interested in a very specific field like, I don't know, health with artificial intelligence, so that will imply that we have to be more precise. We have to select and analyze a different set of applications or a different set of patents, and we can do that. We have the tools to do that in the interactive model trainer. So in the interactive model trainer, we'll have the tools to select these target, identify these target applications, then carry out the topic modeling analysis, and then in the STI Viewer, we will be able to see the aggregate numbers for this selector subset of publications or patents.
Okay, thank you very much, Jerónimo. We had some difficulties to hear you, but I think you more or less were understood by the audience. So I don't know if you want to add something, final question, remarks, suggestion, congratulations on the work done. Yes, we have a question from Juan Ignacio again.
Yeah, again, sorry about that. Only one appointment. I asked for the patents, but I also refer not only the patents, that also the papers and other information. So not only we are centered on the patents, but was only an example. And of course, congrats again, and thanks you for your answer. But that put on clearance in some way with the kind of work.
Okay, thank you very much, Juan Ignacio, for your words. Okay, I think it's time to finish. Almudena, I think you are you are the person in charge of saying farewell.
Okay, just thank you everyone, and it has been very interesting. So we finish now. If you don't have any question more, we finish. Thank you.
Thank you
Bye.
very much. Bye. Bye.
Thank you. Thank you. Bye.
Thank you very much.